Hey, this is number 4 in the OpenPnP Python scripting deep dive series. I'm sharing most of the behind-the-scenes coding work as a walkthrough of how I write powerful Python scripts to control the pick and place and OpenPnP. We're now in the middle of making a cool extension that'll save us lots of work by doing all the basic feeder setup based on a bill of materials file. Now that we've set all the foundations in previous videos, we're ready to hear the magic words,
"I think we're done."
And we will indeed. So far, we've handled the feeders and all that side of things. And now we'll take the feeders, select which parts go where, and do more than just read info from OpenPnP, but actually apply the changes to our config. So now I hand over the mic to programmer me, and we can do this.
Okay, to achieve something similar with the part map, I want to have, right now we've got, we've got this part map that has all these project parts, and we're associating the BOM entry with the part from OpenPnP. But what I'd like is to have access to that package description for this part from the CSV as well. So I'm going to do something similar here as I did before. Package disk. And so we need that here. I'm keeping the intelligence in the mapper so we won't pollute this thing with the descriptions. And so we'll just have the parts, and anything that's mapped will do the same kind of work here as we did with the feeds to get the parts. So let's see. Good ID. There we go. All right. So the part map has a part which has a package which has an ID which we can match on. Oof. So the system seems to be basically working, and if all I have to do is deal with the ICs, I'm going to be in paradise, because the real problem is sticking in all those passives. So now we have mapped our feed set, we have mapped our parts, and the question is, okay, where can we put each of these parts? So I think that's going to get out of the constructor here and actually be in this map function. So where was our original algorithm here? Yes, this. We need to be able to find a feed that can support the package that this part has, and then reserve it in sufficient quantity. So parameter here is going to be how many boards. So num boards. That's defaulted to 4 in a batch. So that way we'll reserve enough spots to have a little batch done, and then have to refill the feeds after 4, let's say, or whatever parameter you pass. So we're going to start by the parts. They're already sorted, so that's wonderful. They know what their package is, so that's wonderful. So all we need to do is then ask the feed set, hey, give me a feed where I can fit in this number. So I don't want to do this in the loop. To assume that we have space for this guy. So how does the feed set know? It figures out if any of its own feeds can fit it. So for How's that? So this will be true if it has space, and then it'll be false if it doesn't. And additionally, well, that's just kind of a side channel thing. I'm returning the number of feeds that I'm actually going to need from this set. So let's see. If it has space for that, then just return it, man. Okay. So no space. Have space. Let's reserve it. Closest. Okay, so we get the closest feed from the set that tells us that we have some space for this part. So find nearest. We're at that point where we need to know the distance here. So great. Find nearest available. We already have our distance from centroid thing. So let's just go. Although this isn't set yet. Okay, we have to do that at some point. We have to do that at some point in the very near future. Okay, so the closest feed is this guy. Now we want to get as many feeds as we need. So we're going to assume that all the feeds in a given set can carry the same number of whatever this package is. So num per feed is this closest feed. Yeah. Voila. Continue. Screw that. Okay, number feed. Okay, this is a feed. Okay, now assuming we need more, what I would like to do is grab the ones that are around it. Maybe one above, one below, one above, one below, kind of like that. How I'm going to figure that out is I could go by distance, but right now you saw that SVG. They're all out of sync because it's the end of one project and it ate some of the feeds and others it did not. So I don't want to go by distance. It's complicated and it'll be annoying. And anyways, if my naming is sane, then 8mm right 2 will be next to 8mm right 3, etc., etc. So I'm just going to sort the names and grab them like that. Wow. Oh, yeeks. T1 dot magic. Okay. So apparently I don't know how Python range works, but you don't actually need it. So screw that thing. But yeah, so finally, we have the workspace here, and I'm going to get rid of all this debug, these breadcrumbs everywhere. That was insane, and I'm not sure what happened, but whatever. So now we have the parts. We have selected some feeds, and I think I just need some way to visualize what we've done so that I can verify that that it makes sense. At first glance, the parts are associated, but I want to make sure that things are happening as I kind of expect them to. So let's say, so we're just going to go over all the feeds and print out if they have anything associated with them and what that might be. So let's just do that. Self.feeds. Oh, look at you. Okay, so starting to look kind of sane, except for a few things. First of all, I'm completely ignoring the actual distance that we have this nice function to calculate, and it's not being put in there. And secondly, I'm not caring about the component types. I'm not doing O402s with blah, 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 blah. So let's see. The first thing I'm going to do is associate the distances, and then secondly, I'm going to have some lunch, and then we'll be back for more. Okay, was interrupted, but got back to business and did some of the non-OpenPnP related stuff for this script. Made things a little bit better. So I'm mapping. Now I'm doing it pretty well. So what I'm doing is that for each part that we've mapped, I get one of the feed sets, and then if it has enough feeds in it to hold this type of package, and it actually accepts to hold them, then we reserve those, and then we move on to the next one. Now it's kind of neat because it goes and it basically asks, give me a feed for this part in this quantity. So any feed that will hold enough of those. So what it asks for is whether the feed set prefers this package. So because I want it to kind of put them together, all the O402s on one side, you know, stuff like that. So the feed sets are pretty smart, and they basically say, you know, I've got no preference, or if I happen to be holding O402s, then yeah, I really want some more, or stuff like that. So the details aren't all that important. What is, however, is the result, because now when we go here, we have our little system, and I can map. Also, I've added, let's see, where's that? I added a couple of types here in the package descriptions. So I'm not sure if these are actually 12 millimeters, but whatever, it'll be fine for the example. The point is, now we've mapped, and if I dump this, whoop, there we go. All right, so sweet. You'll notice that for this this component, there's like 37 for each board, so it's reserving 4. All the O402s are together. Down here we have some O603s, and down here we have some 12 mil stuff and some random stuff over here in this other feed. So that's cool. Now there's little spots. The algorithm isn't perfect, so what I did was I said, okay, just figure it out, and then you can do compress, and it'll basically move everything up. And so it's compressed. If we dump that, nice. So these feeds all together, okay. So that makes it nice and logical. Now the organization is kind of set, but I haven't actually done anything to OpenPnP. So this is, once we're done, so that this part of the algorithm is finished, now we can actually get back to scripting OpenPnP and make those changes to the feeds. So let's see. Right now I've got a job I've loaded, and everything is missing here. There's nothing going on because I haven't set up the feeds. The feeders are here, and they're actually still configured for that old project, so not good. So what we're going to do is say, okay, now that we've mapped it and compressed it, we need a new function that'll say, yeah, okay, apply. So let's try it. Apply. Now what do we need to do? We need to go through each feed set to find each feed, and if it's associated to anything, then take that. All this is going to be stored in these feed info things. We have access to the feed object, the OpenPnP feed, and we have access to the part, which is one of these guys, a project part, so the BOM entry and the actual OpenPnP part is there. So all we have to do is apply that. Now there are a couple of extras. There are things in these feeds that can really be kind of annoying, namely the tape type and the rotation. Yeah, the rotation and tape here. So that kind of depends on the parts. I don't know, maybe we should put that. Is it related to the package? Not really. Some parts, you know, come in strange rotations. or maybe it's my footprints that aren't great. But the point is, I think I'm going to just, for now, reset everything to 0. So, just to make sure, everything is sane. And those few exceptions, well, I can do those manually. So basically, what are we going to do? We're going to go something like... Okay, yeah, we do have something to do here. Let's disable everything that isn't actually being used. And in the other case, we'll set this to true. Okay, so that, reset rotation. Do we have anything else to do? I don't want to play with the reference hole location or anything like that. Basically, I'm using whatever was already there from a previous project. And since we need to do manual alignment, then we're just going to do it, online once this is configured. That actually looks done. Could it be? Could it be this easy? Let's find out. Apply. Okay, so let's get out of here. And let's take a look at our feeders. Actually, what's really going to tell us is this. The job missing over here. That should kind of get fixed, and this will change. So let's take our names like these. Okay, let's see what happens. Map. Yes. Okay, big mess. Press. Okay, that's what we want. And now the magic. Apply. I should have put some debugging in there. Eeks. Okay, we won't see it until this is done. That didn't do nothing. Nothing. Okay, not great. So let's add some debug. Derp. Okay. I'm getting a little tired of this. Let's set the mapping to be automatic because this is boring. Okay. Okay. Yes, that worked. Was all. This looks promising. Oh, changes. Look at all those changes. Okay. Fiducials, yeah, that's fine. Feeders. Let's see what we got enabled here. Does this look like our map? The top has a couple at the front. The left has a couple. Right should have a bunch of 0603s. Oh, look at that. Isn't that beautiful? Okay, this looks like it's going to be working. Now these yellow things, part height, okay. Who's got a 0? Okay, anything that's called 0402. 402. 1.1. Okay. Who else? Don't care about those things. Okay. Well, gee whiz. It looks like this script might actually be working. Let's find out if that's actually the case by using yet another script which is the feeder generate map. Okay, auto feed. Yeah, sure. Yes, 29, that seems right. Look at that. Whoops. Oh, yee. Okay, I changed the direction, huh? Well, whatever. I'm not too sure how that happened, but that's fine. I've got these guys here. I've got those popular guys over there. No. Ooh, okay. Things are stepping on each other's toes because these feeds aren't well placed, but I think we're done.
Sweet. Wow, that took some work. But now we have a set of modules that can do what we wanted. Intelligently do the basic setup for a new project based only on a BOM. Now, everything is working, but it's still pretty manual. So the final step will be to interact with the user. In the next and final video, we'll be doing the top level scripts, getting information and instructions through the GUI and storing useful stuff to run all this wonderful code on command.